morning to all respected professors, dignitaries, and resource person, and our fellow participants. On behalf of Department of Computer Science, Assam University, Silchar, I welcome you all to the second day of these two-day webinar, recent developments in cloud computing, quantum computing, sorry, cloud computing, quantum computing hardware technologies. Our session, the first technical session, will be delivered by Dr. Amitabh Nath, and the session coordinator will be Dr. Pradipta Das sir. I request Dr. Pradipta Das sir to inaugurate the session.
Thank you, Amit. It's my pleasure to introduce Dr. Amitabh Nath. He is basically one of the notable alumni of the Department of Computer Science. He has done his MSc Computer Science from the Department of Computer Science in the year 2007, and then he did his MTech from Tezpur University, and recently he has completed his PhD from NEHU in the machine learning and GIS technology. So that is a short academic introduction of Dr. Amitabh Nath. Amitabh Nath has published many papers in the journals and conferences. So it is our opportunity, grand opportunity, we can say. We are inviting all our successful alumni members, those who are in the academics of different universities, institutions. So Dr. Amitabh Nath is one of them. So I would like to invite Dr. Amitabh Nath for his deliberation. Dr. Amitabh Nath, please.
Good morning, everybody. Thank you, Pradipta. Thank you so much. Yes, it's actually a great pleasure to be somehow be a part of my parent department. I'm Amitabh Nath. I did my MSc, as Pradipta already explained. My MSc from Computer Science Department of Assam University. And then later on I did my PhD and MTech as well. So today, very basic and important stuff. I believe my presentation is visible.
Sir, it's visible. Sir, please can you make it full screen?
Yeah, I'll do it. Yeah, thank you. So as my screen is full screen, so I perhaps might not be able to look at the comments. So I mean, coordinator or maybe anyone can actually me out.
Yes, Amitabh, we will inform you. If
okay. Okay, thank you. So from the topic itself, you can to explain you how we can deal with imbalanced data set and the other few topics also. I've kept it very down to earth, simple and meaningful, so that I do not bore anybody. In my previous experiences also, I have seen when those research topics comes into the picture, students quite often they simply leave the session, or maybe even they're into the session, but they simply go for maybe tea or something else, go for a break. So this session particularly, I prepared something which is very much down to earth, and I'm sure there is nothing which is not comprehensible. So please be with me, and then you will at least learn something from here. Now, the outline of today's talk is something like this: an introduction to imbalanced learning. Then I'll also explain you why basically it's known as class imbalance problem. Some of the possible solutions also I'll try to explain. Then why it is so important. I've also prepared one demo session so that I can show you that whatever we are I'm explaining is actually implementable, and it's very easy. Some Python codes are also there, so that the demonstration part can also be added. As Pradipta also said, that you try to correlate with your research areas, so that people can the research scholar can also become interested, and they can also correlate if it is possible with their domain. And then finally, I'll conclude with the conclusion remarks. Okay, so I've tried my best to mix quite a few things, like the theoretic part, the implementation part, and the research perspective also. Now, as we all perhaps into the machine learning domain, in our time, perhaps the first time I heard the term soft computing from Madam Shahinara. That time we all used to wonder, what is this soft computing, and is there anything called hard computing as well? But now it's a common buzzword. Everybody, it doesn't matter whether research scholar or a graduate student, everybody talks about research, this machine learning and artificial intelligence thing. But what I'm going to explain you is that how, see, what happens is for a MSc student, we, in the curriculum, perhaps we do not have any course or maybe let's say syllabus in terms of machine learning. So what we do is, and even though we are interested to pursue something or do something in machine learning domain, so what we do is we read one or two blogs from here and there, or maybe we look into one or two YouTube videos, and then we start implementing something, let's say face recognition or maybe character recognition, digit recognition, something like that, and we start jump into the domain. But what happens is when we do not follow a procedure, in the sense I mean to say, when we do not follow any syllabus, so what happens is we do not follow an incremental growth. And it's always prescribed that you first learn A, then B, and then C, and perhaps gradually you go up to Z. So in that sense, we lack something while we practice machine learning approaches. And this happened with Mio as well. And I learned with experience, and that experience only I'm going to share with you today. So I'm saying that this is Lemon's approach in model building. So whenever we deal with this machine learning algorithms or more generally, let's say artificial intelligence, what we do is we build one model. And that model perhaps is meant for classification or regression. That means, prediction. And we apply into a particular domain and we try to solve that problem. Now, while doing it, what happens is, I'm sure some of you might have followed this approach as well, or might be following this approach at this point of time. So what we do is we gather some data set, depends on the domain. We somehow download or maybe prepare some data set. What we do next is we build one model directly, or maybe we can do some data pre-processing, and then we directly go for the model. And we do not do any analysis or maybe any test, so to understand with what kind of models can best fit to the problem scenario. One example I can highlight over here. Let's say you have only 50 to 100 100 records in your data set, and let's say these are some numeric continuous values. And what you are trying to do is you are trying to set or fit a neural network. Now, perhaps that's a mistake because neural network, these are heavyweight models, and they require quite a voluminous data for training purposes. And now if you are trying to fit a neural network on say 50 records, perhaps your result will not be good, even if you somehow tweaked your model and got a good result. But then that model performance will not be consistent. That is guaranteed. Okay, it's been proven also. So this is one example. What I'm trying to say is we collect the data and then we start building our model without doing further analysis, so to understand what kind of model can best fit or maybe at least closely fit to the situation. And perhaps we can select something very hi-fi model like HVM, then we can have this decision tree based like random forest, then we can also have this neural networks. All things come into the picture, because this is, as I told you, that the machine learning things, okay, it's simple, but you have to follow steps or procedures. Okay, you cannot jump from here and there. And this happens with most of us because we do not follow a curriculum, or maybe perhaps we have not followed a particular curriculum, so to understand that it has a progressional approach. Okay, you cannot jump from chapter 1 to chapter 5. It might work for some people, it might not, or most of the time it will not work for most of the people. And then what we do is we simply measure the performance. So once we have fit our model, we calculated some results, depends on what kind of situation you are dealing with. And then we measure our performance, or mainly the model performance. Then we see that, okay, some performance is not that good. So what we do, we go back again, okay? And then we tune some of the parameters, because these are this models like SVM, neural network, then your for random forest or decision tree based model. This models works on a lot of hyperparameters. Okay, so those parameters needs to be tweaked. Okay, and they're not constant for different problems. You have to for every problem domain you have to tweak them, change them here and there, and then you try to get the best result. Now we do that, and then finally we again do the performance measurement. But what we find out that from the previous result, the current result is not that good, and then we feel like somewhat stuck. Okay, we are not able to refine our results or maybe improve the accuracy values furthermore. So we feel ourselves that we are kind of stuck. Okay, and then we try to publish, but then it doesn't get published, the result, because the results are not good. And why I have put these slides over here, because as I told you, this is a common scenario faced by most of the machine learning practitioners, and especially the student fraternity we can see in our department as well. They follow this approach. Now, one remedy is, if you think yourself that why did you make mistake, or maybe why you missed something, because most of the tabs are concrete, because this is the process we machine learning practitioners follow. So now if you see minutely, then once you have collected the data set, you cannot help it, because data you are not creating from your side, you are collecting. So I'm assuming that you have collected the correct data set. What you are doing is you are directly going for model building. Okay. Now, technically, there has to be one more step, which is data pre-processing. What we do is we define our data set. Now, again, if you try to put all the refining technique, let's say you have learned about 5 data pre-processing techniques, and you are trying to put all the 5 pre-processing techniques in for your problem domain, perhaps it will not fit. So what we have to do is we have to have an analytical power to understand that which pre-processing technique fits which kind of domain. And for that reason, you can simply plot your data so to understand, or maybe at least have an idea that, okay, this kind of pre-processing technique can be applied, and or maybe the data set can be refined using this particular technique. So in this context, the technique which I am going to emphasize over here is known as class imbalance problem, and you can say broadly it also belongs to data pre-processing techniques. And some of the remedies we are going to learn to handle this data imbalance technique problem. Okay. So if you try to understand what is class imbalance problem, so let's say multi-class classification problem. Okay, so here you have 2 or more than 2 classes, doesn't matter, at least it has to be multiple classes. So just like true, false, male, female, 0, 1, that kind of problems we are trying to deal over here, multi-class classification problem. So now ideally what we want is we want that our balance should be in a perfect situation where the class 1 and class 2 has equal number of distribution, or at least similar type of distribution, data distribution. And